For the first question, we have to transform both sides to get the result. First, we are going to transfer the left side according to the property of conditional probability. So we got that the probability of union of A and B, assuming C, equals probability of the intersection of union of A and B and C over probability of C. And then we got that the probability of union of A and B and C over probability of C equals probability we just simply transform 1 into probability of C over probability of C, because they are basically the same thing, so that we got this term into this term, the probability of C minus probability of union of A and B and C over probability and C. Then we can compare which one is bigger only according to these two terms, because the probability of C's are always the same. Since the probability of C is always bigger than 0, so we got that the probability of intersection of C and the union of A and B is always bigger or equal to 0, because when a union of A and B is 0, then this one could be 0. But for other things that the union of A and B is not 0, since probability C is bigger than 0, this thing could be bigger than 0. This is what we got for this one. And for the probability of union and A and B and C, we can see that it's always bigger than the probability of C, because when A and B, the union of A and B can either be 0 or bigger than 0. So we got that the probability of C minus probability of union of A and B and C will be less or equal to 0, so that we got the since this one is bigger or equal than 0, this one is smaller or equal to 0, so we can get that the probability of intersection of C and the union of A and B over probability of C is bigger or equal to probability C minus probability of union A and B and C over probability of C. So that we go back to the original, we can see that we have proved that probability of in the union of A and B, assuming there's a C, is bigger or equal to 1 minus probability of union of A and B and C over probability and C. And for the second question, which is quite straightforward, because we are told that A and B are independent events. Since also according to the property of conditional probability, that the probability of event A assuming B equals the probability of intersection of A and B over probability of B. And since A, B are both independent events, we get that the probability of intersection of A and B equals probability of A times probability of B, so that we can just cross out probability of B because they're the same. We get that the probability of A assuming B equals probability of A. Uh, and basically for the same thing, because A, B are independent events, so that the complement A and the complement B should also be independent. So through a similar process, we got that probability of complement A assuming complement B equals probability of complement A. And since probability of A plus probability of complement A, that is a whole thing, so that should be equal to 1, so that we have proved that the probability of A assuming B plus probability of complement A assuming complement B equals 1. That's the result.